Hello again. Today we're going to be talking about how to apply some of what we have already learned in this unit. So we're going to talk about some financial mathematics. So let's get started by talking about compound interest. So when you invest money in a bank or some other investment company, that money earns interest. And if the amount of interest grows, depending on the interest that has already been earned in the past, that is called compound interest. And so if you want to calculate compound interest, we need to know the values of a few variables. So first we need to know how much you invested, and we're going to call that P, and we're going to measure it in units of currency like dollars. We also need to know the annual interest rate, which is R. We're going to use a decimal for that, not a percentage. So if it's in a percentage, you need to convert it to a decimal. We also need to know the number of times per year that interest is calculated, whether it's monthly, quarterly, or annually. And we also need to know the amount of time in years that the money has been invested, and we're going to call that T. So with those variables, here's what we're going to figure out. If the annual interest rate R is split into N payments per year, then each payment is R over N. So that interest rate is divided evenly into those N interest payments that you receive. And if that amount is already added to what's already there, then we have 1 times the amount that was already there plus R over N times the amount that was already there. So overall, we have 1 plus R over N times what's already there. And so if this percentage is added on with every payment, and there are N payments per year for T years, then what we have is a multiple of 1 plus R over N to the exponent NT. So if we multiply that by the amount that we've invested, we get our final amount, which we will call A. So that's our formula there for figuring out compound interest on an investment. It is A equals P times 1 plus R over N, all to the NT. So let's look at an example of how this would work. Let's say I invested $2,000 at 5% per year compounded quarterly. How much would that be worth after 3 years? So our principal, our P is 2,000. Our interest rate is 5%, but we're writing that as a decimal, 0.05. N is 4 because this is compounded quarterly, which means it's compounded 4 times per year. And T equals 3 because we are investing for 3 years. So we're just going to plug those values into the formula, and that's what it looks like. And then I can go to my calculator and figure out what that's worth. That's going to be $2,321. 0.509, which I will change to 51 cents. So it'll be worth $2,321.51. All right, here's another example. How much would I have to invest now at 4% per year compounded monthly in order to have $4,000 in 6 years? So now this is a slightly different question because I'm not given the original amount that I'm investing. I'm given what it needs to be worth. And sometimes that's what you need to figure out because you're saving up for something. So I want to have $4,000 in 6 years. The interest rate is 4%, but I'm writing it as 0.04. N is 12 because it is compounded monthly, which means that interest is compounded 12 times per year. And T equals 6 because I want to have $4,000 in 6 years. So I'm replacing everything except for P because that's what I'm trying to figure out. I'm trying to figure out how much I should invest now. Well, to solve that, I would need to divide both sides by everything that P is being multiplied by on the right. So you see 4,000 divided by all of that. And once again, I can go to my calculator and figure out what all of that is worth. That's going to be $3,174.77. All right, the next concept we need to talk about is inflation. So that's basically an increase in value of something over time, and it's expressed as a percentage per year. So the value of things goes up as time goes on. Things are worth more than what they used to be. And so we can calculate how much it goes up, and we can even predict how much things will go up in the future. So if you're saving up to buy something, you need to account for inflation because the price is going to go up by the time you've saved enough. And the formula for inflation is the same as compound interest, but you only calculate inflation per year. So you don't calculate inflation monthly or quarterly. So your n value is always going to be 1. So anywhere there was an n in the previous formula, now that's replaced with 1. So r over n in the old formula becomes r in the new formula, and the exponent of nt in the old formula simply becomes t in the new formula. So for example, if we had a sculpture that was worth $8,000 today, inflation averages 3.5% per year. Find the value of the sculpture in 10 years. Okay, so the original value is $8,000. The interest rate, or the inflation rate rather, is 3.5%. So R is going to be written as a decimal of 0.035, and time is 10 years. So we plug those into the formula and we get a value of $11,284.79. And the last concept that we need to talk about is real value. Real value is calculated when we want to save up money for something that is in the future, but we have to account for the fact that it will be worth more by the time we've saved enough to buy it. So the formula is very similar to one in which we calculate how much we need to invest now in order to have a specified amount of money after a certain number of years. And so we're rearranging it so that we are solving for P instead of solving for A. All right, so here's an example. You will invest $8,000 in hopes of buying a new purse. How much will that be worth if you invest 6% interest per year, compounded monthly for 5 years? And if inflation is 2.5% per year, how much does your desired purse cost today? So there's our formula for compound interest because we are investing money. So it's $8,000 is my P value, R is 0.06, and N is 12 because it is compounded monthly, which means it's compounded 12 times per year, and T is 5 for 5 years. Okay, so after I invest $8,000 for 5 years, it will be worth $10,790.80. All right, so now if I take that and I plug that into the real value formula, my A is going to be $10,790.80, which I just figured out. And I'm going to divide that by 1.025 to the fifth, because again, it's 5 years and the inflation rate is 2.5%, which is 0.025. So if I figure all of that out, I get $9,537.50. So that's how much my desired purse will cost today. All right. So that is a few of the elements of financial mathematics. If you have any questions about that, please let me know and I will see you tomorrow.